Hi there, this is just a quick video regarding the data from the recent visit to Eshott, just in case you've got issues accessing the USB. What I'm going to do is just very quickly show you the key graphs and maps and basically explain what's going on. Hopefully you can use this video to pause at any particular point that you might find interesting. The first bit I've got on the screen right now, obviously there's no video for this, unfortunately, the camera wasn't working, but the first thing I've got is when this particular data set, there's 4 parts to this. So the first part, you can see if I drag the cursor across the screen, we've got the ground speed in miles per hour, and on the x-axis we are measuring the time. You can see down here, click the time button. There's nothing really to comment on this. This is just so you get a rough idea of what's going on as the videos and data sets progress. Right, so you can see time equals 0, nothing's happening, and nothing in this particular video actually happens until we get about 2 minutes in. So I've dragged the cursor to just before 2 minutes 20, and what you'll find is on the map on the right hand side, it should start to move with the aircraft. So the aircraft actually starts to taxi along the runway from the starting point to the end. It then goes into runway number 2, where during this point, the pilot will be testing the flight controls. And obviously, it's priming to get into the takeoff position. So as nothing particularly happens there, you can just see the aircraft start to move along the ground from about 2 minutes 17 all the way to a little over 4 minute 20, so probably 4.5 minutes there. So that's it. Not much to see in that video. Right. In the data sets, if you look at this particular screen, the first one I did pick there was the earliest one. So I know the timings aren't in matching what we actually done on the day, but it's probably because I've just copied these over. 1822, obviously the earliest time. You can see this is going to be the form. It's about a 4-minute video, this one. So this is probably the one I've just opened. Right, obviously, this aircraft obviously went back and forwards a couple of times there, right? So this is the same principle. Ground speed, distance covered, or time covered. It's the same graph, basically. This is the one where I started off because of the earliest point. So this is the graph I've just explained where it's come from. So as I say, we started 4 minute 20, we taxied to our relevant point, so we haven't actually physically done anything. In that particular path, though, the aircraft has travelled quite a bit of distance there. 3,300, 3,000, maybe 500 feet there, going from the starting point to the end of the runway number 1 to runway number 2. Right, into the next data set. So that was the 1822. The next one, let's see what this is. Right, so this is 1827. Doesn't look like much has happened on that one. Right, this is probably the main one here. So you can clearly see we've got about 13 minutes. This is probably going to be the main aircraft flight. So there's our loop. Just loading the map up. Right. First thing I'll do then is change the x-axis to time. Right, this is just going to basically explain where the first few seconds of the video come from, and then you'll be able to analyze the actual data in a second or look at the data. So you can see the first video of the aircraft went from the runway, the starting points are where all the aircraft are parked up near the flight club. We taxied along this runway here, got to the end and entered for runway number 2, or part of runway number 2. Got to our starting position, and what's going to happen here is, if I just drag this a little bit, you can see the aircraft starts to move off in that direction, and then it's obviously taken off. Right, a few key points you can see down here, so I might actually leave it like this. Time during that first little section there, if you take a close look at the altitudes, it's 192 feet. Obviously, that's equivalent to sea level at the moment, based on the airport. We take off, and the altitude starts to increase there. The aircraft's clearly taken off. We've gone from 192 to 196, and we're off. So it doesn't actually take much of the runway to physically get airborne this aircraft. Do that in terms of distance. I'll put the graphs on in a second. This is what these will be modifying. This is just give you the rough idea. So aircraft takes off, it does a loop. In this particular flight, we've headed off to the east coast, not far off the island over there. Unfortunately, don't know the landmarks. Head off to the east coast. We've then got towards the very end. We've looped back over, and we've come in for a very quick descent. So obviously this seems to be one of the shorter flights in the air, and you'll see that towards the end of the video, the dot should come back in somewhere around now. There it is. Just towards the end of the video, it's landing, and then back to the start. Right, so obviously there's a couple of phases here to start examining. Right. Based on the markings here, we've got point 1, which is basically the first half of the loop, as you can see there. We get around the halfway point. Just ignore the graphs for now. This just give you the rough idea of what's going on. We've looped back over. We come back in towards the airport. We'd start descending. We've hit the ground, and we've finished taxiing at this particular point. We're then coming into point 2, and then this is part 2 of this video, if you like, and this is where the aircraft's going to basically taxi back to the flight school, and the flight's totally finished. Right, so we're going to start at the start and see what we've got. Right, this video starts at the point where the aircraft's taxied to its point ready to start off. And the first thing I'm going to show you is the altitude. One graph at a time. Right. And see, it doesn't take very long to actually get airborne. Right, so this particular graph, you can see has its starting altitude, and within, and say it's in up to interpretation on the axes here. But you will see we've got a gradual rate of climb in terms of the altitude. We've climbed up to about 1,500 feet and we've hit our maximum altitude. Most of this flight appears to have been in cruise condition. So from 3 minutes, arguably to around 7, we maintain constant altitude while obviously you can see based on the map, the aircraft's flying around, does this loop, comes back in around here. And you can see the blue bit is the descending. So based on the color coordination here, red is the taxi on the runway, yellow is the climb out, along with the blue. Green appears to be the cruising flight, where the altitude doesn't particularly change. The second blue part is the descent, and yellow is back into ground condition where you hit the runway in the red. So the red part is the aircraft on the ground. And so start that again. Now we are, we took off, we're climbing, we're climbing, we're climbing, we're climbing, we're climbing. We're doing the maneuver, which is probably why it's changed colour. Hit the apex or the peak of this graph. You can see just before 3 minutes. Moves across, and we are in constant altitude roughly up to about 7 minutes. Slowly descending, and you can see we're clearly starting to descend towards the ground here, and after about 12 minutes or so, we appear to be back on the ground in total. Right, so that is the altitude. Well, the main flight. The maneuvers. Start any roll. I'll take the altitude off. Right, there appears to be some rolling maneuvers going on early in the flight. There's the main significance. So we've got a negative roll. This is positive and negative basically indicate whether it's banking right or left. About the origin, seems to be quite a perturbed flight, this one, although there's no major banks apart from the start. So if I drag this map across or this cursor across up to here, it's probably this point where we took off and we started to bank straight away as part of the climb out. This is it there. This is the roll of the aircraft. It actually hasn't done an awful lot while we're banking. It settles down a little bit in the main one. These are going to be your angles of bank. You can see how fast they're occurring based on the angle per second. If we have a look at the latitude, not the latitude, sorry. The pitch rate. So this is how fast we're pitching up and down. So this is a change every second. Right, so these are the extreme pitches in the aircraft flight. See the first bit, it will coincide with the fact that we pull back on the control stick. We're coming up out into the ascent. We're still climbing. Obviously, it'll be a bit of aircraft stability involved here, hence the rather volatile motion in this graph. But the peaks are the major maneuvers you can see. We'll get to this point here. We've got a bit of an ascent going on. We pull back on the lever. Got another one here. So this is where we appear to be starting to come back down. The pilot's starting to descend. We're modifying the pitch rate in order to do this, descending, descending. And then obviously we've hit the ground, hence a little bump here. Right, so just leave it there for a few seconds in case you want to take any pauses and data points. Right, and the last one we haven't looked at is the yaw. Take the pitch off. Right, the yaw appears to be a bit more obvious of what's going on here. Right, small aircraft like the Cessna 150 might need to discuss a little bit about yaw dampers because of the prominence on the Dutch roll. They're very prone to things like this small aircraft. Right, so starting as we go, we've taken off. This is the point of takeoff around here. We're doing the yaw, so the aircraft's putting quite a bit of rudder pedal in at this particular point as we take off. It's probably battling against some strong winds. We've got a first major yaw point here, so you can see this is where the aircraft starts to bank. To turn rather, and we constantly turning at this particular point, so you can see quite some sharp peaks in this. It's rates, it's angles involved in this, so it's this is sorry, this is per second as the time goes on. We seem to have settled at this particular point, and then there's a sharp bend here, as you can see on the graph and the map. This is where we turn and back towards the airport. There's some sharp turning motions here. I'm coming back in, and obviously the pilot's starting to line back up with the runway around here, hence there's a big dip. Then there's a bit here where we descend into the ground. We've hit the ground. This is now just controlling the aircraft on the runway, these peaks here. And so remember, your rate on the y-axis, time on the x. Right. I'll do them in order again. We looked at the pitch rate first. This time in terms of the distance covered. Effectively the same graph as the pitch we've seen earlier on. You'll probably see the same concept with the roll and the yaw when we get there. So the roll on. Here you can see doing quite a bit of banking as we're coming into land. It might be worth speaking about the atmospheric conditions that day. It's very windy, hence there's quite a bit of rolling motion, quite a bit of yaw motion going on, as you'll see in the yaw rate when I take pitch one off. So as we've covered the distance, there's some strong peaks to point out or discuss. So my advice, take some screenshots, highlight the sections of interest, see if you can get some calculations based on angles and rates of turn and banking. Do the heading graph and take off. Right, heading is more a degree based thing, so which way are we facing at any particular point? You can see as we take it off, there's not much change in the heading. We start to turn, we change the heading angle as we go around the map. It's fairly linear, and then there's a very sharp bend. There's a very sharp bend, so there's a big increase in direction we're facing. Levels itself off as we come into land. Same for the time. You can see it should line up with the times there. Right, there's the turning motion as we climbing out. It's still turning, it's still turning, it's still turning back in on itself a little bit. Sharp turn here. And then it settles itself back off. Right. I don't think there's much else to really point out. If I do the ground speeds to finish off, this might be seen better on a different graph, so you can open one up. I think that one is. I think that appears to be it. So put that main video back on. I'm going to look at the ends and the starting bit. So this is the takeoff distances, takeoff times, and the repeat for the landing points. So and just maximize the graph here. If you change the graph to altitude, it's watching this number here. So just to show you where I want to start pointing now, it appears to be taken off about there. The first fluctuations probably just the general bumps and troughs of the airport runway. So 192 feet, it doesn't really drastically change until we start to get around this particular point. Right, I'll show you this on the graph in a second. And likewise, there'll be one at the very end. So if you keep an eye on, we're still airborne, only just this particular point. Still airborne, we please descend, probably hit the runway about that particular location. Let's settle back off, and then you can see it's starting to taxi around at the end there. Right, show you this on. Right, this is probably the rest you can see. Right, altitude stays constant. So this is the point at the start of the video, basically here. Hasn't took any distance. As you go across, unfortunately, the measurements are in feet. So I think we can change. Right. Unfortunately, it's in feet, but you should still get the concept here. So you can see the very first change in this graph is here. After it traveled about 700 feet. point at 700 feet, you can clearly see we're starting to take off. Our altitude's going up and up and up away from the airport altitude. So one of the performance things you can comment on is how far we require to take off, or the distance required to take off in this instance, based on the conditions. If you repeat the same process but change it to the time, didn't want to zoom in for some reason. Right, obviously it's not zooming in, but you should be able to see, if you can read the scales roughly. 1 minute, 2 minutes, way beyond the 1 minute point, probably way beyond the 30-second point. It probably won't need very much time to take off this aircraft. And try and do the same thing for the landing points. Right, landing. See, it's a cumulative graph this, which doesn't help, but you can see we're descending, we're descending, we're descending, we're descending. We've hit the ground. This is the total flight distance we've travelled, 85,500 feet. And the end of this video is basically the end of the distance required to land, because after that it just taxis into the next runway ready for parking. So 85,500, and it's gone to 86,300 feet in terms of its distance required to land. For the time, unfortunately, it doesn't let you zoom in, but it's virtually minimal. So not really easy to comment on the time aspect, I'm afraid, but the distance is very easy to comment on. Didn't require an awful lot of time to take off or land. It's obviously a small aircraft. Been through the rest of the criteria, where I've had a quick look at the pitch involved, the pitching rate as the flight's gone on, the rolling rate as the flight's gone on, and any turns based on the yaw as the flight's gone on. In terms of the analysis, just make sure you take any screenshots that you might feel is relevant. If you want to talk about the distance to take off there, it might be worthwhile. Take that back to the start. Right, there we are. Right, so it might be worth just pointing out it took about 490 feet to take off. So this is the type of graph that you might want to take a quick snapshot of. Snippets, comment on it, what's it shown? It's shown that the aircraft requires about 400 to 450 feet to take off. Similar thing for any climbs and turns that you might find relevant, any maneuvers. Obviously, as part of the day, you experience the atmospheric conditions. Well worth commenting on them, because if we have a quick recap of pitching, once we get a little bit more airborne. Right, we clearly airborne at this point, so variations in the pitching and the altitude comes about from the fact, obviously, a bit of a windy day. It requires a bit of trimming for the aircraft to maintain a constant altitude. That winds will also induce some roll. Obviously, this starts linked to the stability aspect of the airframe, and similarly to the yaw, some sharpish turns in this particular bit. Now we've zoomed in a bit. So halfway, just complete the first main turn. We're starting on the main flight path. It's in a straight line. We can see there's some turns involved, probably, as I say, linked to the wind factor. So remember, comment on the winds, the atmospheric conditions, and finally, anything the pilot might have said to you. So you'll have experienced the first part of the flight, obviously, and the pilot will have mentioned a few concepts based around the aircraft, based around the aircraft performance, how it handles, what to expect. Make sure you include them. It's a very small section in terms of the actual analysis. It's just getting you used to the bit of software that you can use to analyze aircraft, the data, its flight path, etc., and making sure you can link the theory to the previous stuff we've done. Hopefully that gives you enough information to work with. If there's issues, just drop me an email.